It's just a follow-up video where we are going to cover a little bit more in depth on the closed zone system curves, how to run that, including some specific tips and tricks, and actually go in through and show an example of how you would actually run this. So a closed zone system analysis is something where you've got a pumped only zone. So you've got a, a model zone where you have no tank. It is just a pumped only zone, so a pumped supply only. In those kind of situations, you cannot use the system curve analysis tool directly. The reason for that is because the way the tool runs is it does from zero supply up to the maximum supply. And on that zero supply in the model, when there's demands in that closed zone and I have no supply, the model will crash. And so when that happens, hey, I can't do that. And so that's a problem. And so you have to run these closed zone analysis system curves kind of manually. And we're going to show you how you can do that. And a couple of the keys because of that is you need to have a situation anytime you're analyzing a closed zone is supply must equal demand at every analysis point. And all your pumps need to always be inactive or off because of how you do this. And if you've not yet seen either our system curve presentation or our system curve water talk, we recommend before you proceed to actually review those because we cover a lot of good material there and go through that in a whole lot more depth. And there's a lot of background material that'll make these make a whole lot more sense. So if you've not yet reviewed that, we do recommend you stop, go find those, and then come back and then pick up this. But assuming you have reviewed those, let's continue. So the way the model does run this, and when you run this manually, we're going to do it just like the model does. So we're going to pick a specific node on our pump station, the one that's on the suction side and one node that's on the discharge side of the pump station. On the suction side node, that's going to where we're going to put our positive demands, and on the discharge side, that's when we're going to put our negative demands. Those are going to be the supply, okay? We're going to need to identify uh, a, a tank on the discharge side where that is going to set the hydraulic grade line requirements for the closed zone. And essentially that's going to be based on, hey, what are the pressure requirements? Usually, hey, I know I've got some minimum pressure requirements in my closed zone. A lot of times that might be something like 40 psi minimum. So I need to find my highest elevation and make sure, hey, what is my minimum pressure that my customers are going to need? If it's different than 40 psi, whatever that is, for instance, let's just say it's 40 psi or 50 psi. If it's 50 psi, you know, 2.31 feet per psi, so 50 psi is basically 115.5 feet. That would be the equivalent of 50 psi. So, you add that to the elevation of that junction. If I had a junction at 100 feet, so 100 feet plus that 50 psi or 115.5, that would be the equivalent of 50 psi. That would be that hydraulic grade line, or 215.5 feet that I'd be shooting to meet. That would get me at that elevation 50 psi. Okay. So whatever your node elevation is plus your minimum pressure requirement, that's what you're going to be setting. Once you know that, and that's usually at that highest elevation junction. But you may also be concerned that, hey, I might have a junction that's maybe at a slightly lower elevation, but it's much farther away. So I've got a lot longer pipeline that it needs to travel. That may also end up being a critical node. And so I might need to test both of those points and see which one ends up having a higher hydraulic grade line equivalent at the discharge of the pump station. Whichever one has the higher one is ultimately going to be the one that's going to control. Okay, so once we identify whichever one of those points is, and you're probably going to need to run both, or maybe I have two or three that I think might be critical. You're going to want to run all three. I'm going to set that up. I would recommend doing your dummy tank is essentially set the elevation at your hydraulic grade line goal minus 10 feet. So if I had that 215.5 as my HGL goal, I would subtract 10 feet from that. That would be the elevation of the tank that I would put. So 205 0.5 feet would be the elevation of the tank. I'd set my max height of the tank at 20 and my initial level of the tank at 10 feet. That would put the hydraulic grade line for that tank right exactly at 10 feet, okay? And then I'm going to need to connect a pipe to that tank. I generally just want it large enough, but it's not super critical because hopefully I'm not going to have any flows going in and out of the tank. I'm just setting it so just have a tank, that's there. The diameter 10 feet. I don't want it too big. I don't want it too small. Just large enough that there's some storage volume that's there with a pipe. It could be 8 inches, could be 12 inches. I just need some connection so it's hydraulically connected. And then I need to sum up the entire demands of all the junctions that are in my closed zone so that I know, hey, this is the total demand that's there. And I need to look at all, the demand 1 through demand 10 categories and get that total demand that's there. That's the base demand that's there. That's the demand that I'm going to need to match, okay? And so let's look at our model here really quick so that we can kind of see this. So here's my closed zone, and I've went ahead already and I put these in my closed zone uh, for my system, and those are there that are in my closed zone, and those closed zone nodes. Um, so I've got all my junctions in my domain for my closed zone. And so let's go ahead and look at my database editor here. And I'm going to do my junction demand on my domain. And you can see, let's go ahead and sort these. Already pre-done a little bit of work here. So uh, uh, these are all the demands. Ignore these high and low nodes. Those are my suction and discharge nodes for the pump station, but let's assume those don't exist here. My total demand for that is 155.8784. Okay, so that's my total demand. And we have a little spreadsheet that users can use for a closed zone. And so if I put that total demand in that closed zone here at 155.8784, in this base demand field. And then let's say I want my system curve to go up to 300. Then I put that total demand. If I want it higher, I can change that number. Then it will create a demand pattern right here for me. And so it's got 14, values here, actually 15 values because there's a 0 pattern. So I need to have a pattern with 15 values. So I can go into my model, and let's go into here and let's just select one of those junctions right here. And you're going to need to create a pattern. I've went ahead and created a system curve pattern for myself. But if you don't, you can just say, a new pattern, whatever you want to call it, and then say, hey, I'm going to set the rows for this right here, say set rows, and you need to set this equal to 15, right there. And then in your spreadsheet, copy that, Control C, and then go back to your model, and then you can paste that in there. And now I've got all 15 of those patterns created. that are right there. And then those are going to be the ones that we're going to use, just so that I'm already using the system curve pattern that I created. I went ahead and changed that back. But in your model, generally you would go to your database editor, into your domain, and then you're going to need to change all of those, patterns in your domain. Like I said, I've got my suction node and discharge node for my pump station in here. So those are also going to have that pattern, but those are going to be assigned that new pattern that I've got that are on there. So if you don't have those, and let's zoom in on that pump station, you know, and so on my pump station discharge, I'm going to take that total demand that I had in my negative of that. So that negative 155.8784, I put that in there. Most of the time, you're only going to have 2 decimal figures. I went ahead and increased my decimal figures because I had one of my junctions, I forgot to put the pattern on, and I was thinking that it was that, but usually you're just going to have those 2 on there. On the suction side, that's you're going to have your positive demand, so 155.8784. Okay. Once you've identified all of those, now the rest of my system, I'm going to need to change all those patterns to a constant pattern. So if I want to go into my domain manager, and then I'm just going to go ahead and do the inverse. So these are all the patterns that I want to change are in my current domain. I hit the inverse button, and that's going to switch the domain to, hey, everything that was in the domain is now not in the domain. And so now I go into my database editor, open the junction demand again for my domain, and you can see I've already done this. I've created a constant pattern. If we can see what that is, this is just a single pattern with one value equal to 1 that's on there, so that now that all of those demands are going to be equal to a pattern of 1. If you do have demands in demand 2, 3, 4 through demand 10, you're going to need to do that for those as well. But I've already done that for mine. So, and now just so that I can get back to just having my active closed zone in the domain, I'm going to go ahead and switch my domain using that inverse button again. But now I've got my discharge node here with my negative demand. I've got my suction node with my positive demand that's on there. And so you can see I've got 3 locations with my discharge tank. And so let's go ahead and switch which one of those is the active one. And I'm going to make this tank down here currently and its pipe the active one that's there. And so what we did in this location, this one had an elevation of 5941, and just based on the HDLs that we needed, I identified the key elevations and the pressures, and set that tank up. I think in this case it was a little bit arbitrary, just because of the original pump that they had here was a little bit weird for this, so we had to lower the HDL a little bit. Otherwise, this pump was operating very close to its shutoff, and so we dropped it a little bit. But that's generally not going to be the way you're setting this hydraulic grade line. Generally, it's going to be, hey, I need exactly, hey, in this case, they had 62 PSI, here. Or I think in this case, this other was my lowest pressure, but whatever in your case you need to identify, let's go back to like the max day and see what the pressures were on this case here. So like they had, I think our lowest pressure at this point was, whoops, I'm looking at the wrong result here. So let's rerun this scenario here. Let's do the EPS run so that we can actually see what those pressures were, and so that we can see, hey, my lowest pressure was about 45-ish at this one location that was there. So hey, 45 psi right there, and hey, at this location, what were they seeing? Just so that we can compare that. Hey, this one was getting down to 55, but again, this is probably one of the more farther nodes that was there. So, that's kind of why I ended up choosing these 2 points. This was one of the higher elevations. This was one of the farther points. And so now let's go ahead and run this. And let me just make sure this tank is inactive. And whoops. Give me a second here to make sure I didn't. Yes, I did. I accidentally inactivated something that I did not want. And okay, so now I've got, and I don't want this tank active here. I want this guy active. So now, and let's go back to this close zone. So what I did is I made a new scenario that was in IntelliSelection, and in IntelliSelection, it will remember what you had active the last time you were in it. So that's what's active here, and why those were inactive there. So just so that we've got it. So I've got my demands all set up properly. I've got everything constant everywhere else. Let's go in and look at the time settings that we have set up here for the system curve. So we're running at 14 minutes. Our hydraulics time step is 1 minute. Our pattern time step is 1 minute. Although it doesn't really technically matter what our quality time step and our rule time step are, we're just following good practice, which is setting those at 1/10 of our hydraulic time step. Again, if you're not doing a quality run or using rule-based control, which we're not, these really technically don't matter, but it's just good practice. Our report time step is going to be every minute. So we're setting that at 1 minute, and that's basically what we're going to do for a system curve run, okay? So everything is all set here. There's no tank in the suction zone over here. So in the suction zone here, this is all supplied by PRVs. So there's nothing that is adjusting the hydraulic grade line on the suction side over there. So there's not going to be any family of curves. It's going to be one of those special cases where there's only one system curve that's going to be possible. If there was a tank in the suction zone, then that wouldn't be the case. But in this case, we only have one, thing that is controlling, and so that's going to be the case here. Not often the case that will happen, but just one of the unusual things in here because we're in a PRV zone. Those PRVs are setting the hydraulic grade line on the suction side of this pump station. And then on the discharge side, there's obviously no tank, just this dummy tank that's keeping a fixed hydraulic grade line, but it's not filling and draining. It's just keeping a constant HGO. Okay, so that again is what we're trying to do here. We're just got all our pumps are off. We have got a dummy tank put in. We have got a pattern assigned to all our demands, and that we've got all the operations set up just like this. And so now we're ready to run our system curve. And then once we run, we're going to do these checks to make sure there's no flow going in and out of our tank. If there's not, then we know that we've balanced supply and demand and we've kept that just the way that we want it. And that we know that we've kept all the demands outside the system constant, so that we've done a very short run, so that we've pretty much kept the outside boundary conditions as close to constant as possible, so that they don't change. Okay, and that's pretty much what we want to see. We don't want to see them changing. We want to see those stay the same. Okay. So let's go back to the model and we can actually see this, and we will actually run this now. Okay, so let's go ahead, and now we've got our runs on there. And so let's go ahead and run this. And so now we've run our system curve. And so now we're going to do a couple of checks. First, we're going to go and we're going to see if our tank had any flows going in and out of it, and it did not. And so that's good. That's what we're looking at. And so you can either look at the pipe that's connected to it, and you're basically just looking, hey, there's no flows on it. If there's no flows, then hey, I did perfectly balance my supply and demand, and that's a good thing. And so then we want to take and we want to graph everything. Let me go ahead and remove all these graphs that I have because I have a few too many on here, just so that it's cleaner. So when you graph this element, we're going to go into the report that's on there, and we're just going to highlight all these columns, and we're just going to copy that. And so we're going to go back into that spreadsheet that we created. And so this was the discharge node. So I'm going to go to here, and then I'm going to paste that, and then we're going to go back to the model and hide this, and then we're going to go into the suction node, and we're going to do the same thing. So we're just going to graph it, and we're going to go to the report, and then we're going to highlight all those columns, do a control C, or highlight it and copy. Both ways do the same thing. We're going to go into here right under the time, and then we're going to hit paste. And so now that just pasted in the results, and this is my system curve with the tank in that location. Now I've already went ahead and put in that current pump curve that's there, so that I've identified it. And if I can say, hey, at that critical junction that's there, if I want to look and say, hey, hey, let's take a look at my discharge node, and look at those results, then I can say, hey, if my highest flow that my station was providing was truly 300 gallons a minute, then the discharge pressure at the pump station would need to be 122.6, or ahead of 6,086 as a head in order to maintain the pressure at our tank that we wanted to get. That head at that tank, let's go ahead and look at that tank that's over here, and we can plot that, and we can see, hey, let's look at the report. We can see the head on that tank stayed constant the entire time. So if that head, which represents that pressure at that node, let's go ahead and plot, this is, say this was my critical node. We'll notice, hey, if we looked at the pressure on that, it was constant 60 psi. If that was my goal, that hey, this customer needed 60 psi minimum, that was whatever requirement that we needed. Hey, what kind of head would I need to discharge here at my pump station in order at the maximum flow to keep that 60 psi at that far away customer? That's going to tell me, hey, I'm going to need, let's go back to that report manager and look at that discharge graph. That's going to be that head of 6086, or a discharge pressure of 122.62. Okay, so I took that and then I set up my tank to say, hey, you know, uh, you know, 6086 minus 10 feet, 6076, right? So I just basically made the same tank at the same HDL requirements, just subtracted 10 feet, gave it an initial 10 feet level there, so that I can set that hydraulic grade line. And now I'm going to make this tank inactive, and then I'm going to make this tank active. And then now I'm going to rerun my system curve, but now with the tank at the discharge, you know, and if I do that, I've actually got these copied already, and that is this curve, and so if we actually look at these, you can see, just as I kind of switch between these, this one is pretty much just flat as a pancake, which is what you're going to expect if you're running a variable speed pump station with a constant discharge. That, hey, that my system curve is not going to be very exciting. It's going to be essentially flat no matter what the flows are, so it's not exciting. It's not increasing like it is when I'm trying to keep a HDL somewhere else and the flow is increasing. I'm going to have to be pushing in more head in order to do that when I'm trying to keep a constant HDL somewhere else. But this tells me, hey, what would you need at the station? And then I can use that to set that pressure so I know what that pressure is at the station in order to meet that requirement at that farthest customer. And if I'm unsure, hey, was, you know, this customer the critical one, or was this customer, I can run both system curves for both those locations, find out which one of these had the higher pressure at the discharge, and that's going to be the one that's really going to control. And this is essentially for a closed zone, why those become an iterative process and how you go through that. You would just run this multiple times, but again, this is how you can use this, you've identified the total demand in the zone, the maximum flow that you need to run your system curve. Here's the pattern that you have. You assign this pattern to all the demand nodes in the closed zone, as well as to the suction and discharge nodes that you will use for the pump station. Uh, the the This base demand will be applied to the suction node with this pattern. The negative of this demand will be assigned to the discharge node. And then this pattern will increase the demand, and we'll see the system demand slowly increase. If you look at the system curve, the flows slowly increase from, is not exactly zero, but as close to zero as you can get, all the way up to the maximum value. But hey, this is pretty much good enough. Close to zero, it's like what's the value? You know, uh, uh, 1.55 gallons a minute, as close to zero as you can get. But hey, that's good enough, all the way up to your maximum value. And then you can see, hey, identify which one is that critical node. And then once you identify that critical pressure at what I need at the discharge, I can rerun it with my dummy tank at the discharge of the pump station. And then this is going to be, if I'm going to use a variable speed, which usually you are in a closed zone, what my discharge pressure would need to be, and then I can use this to evaluate different pumps that I'm going to put at my closed zone. And in essence, that's as simple as what it would be. And so, pretty much that's how you would do that. And why you need to put in that dummy tank, because that's what's going to determine that hydraulic grade line. Otherwise, there's no hydraulic grade line for it to even know how to calculate it. But that's what's on there. How you can use that spreadsheet that we have, again, that's provided as is. It's your responsibility to verify the calculations that are on there, but that can help you calculate those patterns. It can help you, calculate that's on there. But and again, always verify that no flow is going in and out of the tank. As long as there is no flow going in and out, you know that you definitely balanced the supply and demand and got that on there. So, but that's pretty much how you do a closed zone analysis, what this spreadsheet looks like. Inside the spreadsheet are these detailed instructions that are on here that are included in this presentation, that show you how to have this pattern and how those go. And let me show you on that. It's on this README thing of how it goes. It even says, hey, calculate the total demands in your model, where to put that in that cell, identify the maximum flow, where to paste that, you know, copy the suction node, where to put that, basically step by step on how to do it. Some other key things, hey, you're going to have to create a new demand pattern in your closed zone. You're going to have to, hey, we do recommend you make a new scenario and a new demand set, because those patterns are going to be changing, and you're going to be putting new patterns on that suction and discharge node. So it's a good idea for that. Probably a good idea to have a new control set, because you're probably going to be turning things on and off. You may need a new tank set if you're changing anything that's on there. Again, if you do have a tank on the suction side that has a low and a high level, then you may also need to create two scenarios, because one, when the tank is at the low level, one when the tank is at the high level, because those are going to be your ranges of suction pressure, and so those are going to change the range. You're going to have a range of system curves, a low system curve and a high system curve. Just keep that in mind. But again, just walking you through all these things, and then, a couple of slides that come from the original system curve presentation on, hey, just how you do this, and just kind of, how you get there, and all that good information that's all in this README slide, that's on there. The actual Excel file will not have two of these tabs on there. It's just going to have this one tab that's on there, but you can use that to do it. But again, that's how you do a closed zone system analysis, and we'll walk you through that. Thank you again, and have a wonderful day. And contact us at support@innovyze.com if you do have any follow-up questions. We're always glad to assist you. Thank you.